So solving a system of 3 variable equations, usually the strategy here is elimination method. And we use Gaussian elimination to help us with this. The strategy, very similar to the other elimination method, is you want to eliminate a variable. You want to try and see which variable is kind of like easiest to get rid of if you were to like multiply things by a number. So all of those things still apply. The strategy is also that you want to eliminate the same variable as you start breaking it down. So for us to eliminate things, you need to have 2 equations. So the question is, can I create 2 equations from these 3 equations where I can eliminate a variable again? And so what we want to do is we want to pair one equation with the other 2. And the intention is with those 2 pairings to eliminate the variable. So it looks like the x's are very easy to eliminate. So I want to pair, I'm going to do equation 3 with 1 and equation 3 with 2. So equation 3 with equation 1. And equation number 3 with equation number 2. So if I did 1, 2, 3, equation with number 1, and then equation number 3 with equation number 2. Just to visualize it. Now, my intention here is I want to eliminate x. X seems like the easiest. Like I can multiply this by -2, I can multiply this by -2, and then by doing so, I'm going to be able to eliminate it. So that's -2x plus 12y minus 8z equals 24. And then multiplying this entire equation, you get -2x minus 2y plus 8z, and this equals -24. So adding these together, the x's cancel out here. You get 14y, and then minus 3z, and then here you get equals 9. And then the x's cancel out. The y's cancel out, which is nice. And then I get 13z equals, and then 15 and 24. That gives me -39. Now I can divide both sides by 13. You're going to get z equals -3. Now I can work backwards. I can plug my z into this equation. So you get 14y minus 3 times -3 equals 9. So 14y equals 0 if I subtract 9 on both sides. So y equals 0. And now I can plug both 0 and -3 into the next equation. So I get x minus 6 times 0 plus 4 times -3 equals -12. So I plugged it into this first equation here, both my x and y, or sorry, my z and y. So this gives me x minus 0 is nothing, minus 12 equals -12. Add 12 to both sides, get x equals 0. So my point is 0 for x, 0 for y, and -3 for z. And if you're wondering what order, just look at this: x, then y, then z. And this next one, for number 3, do I want to eliminate the r's or do I want to eliminate the s's? Probably the s's, because then I would only have to multiply, one equation by a number. So again, I can pair equation number 3 with 1 and 3 with 2. So equation number 3 with 1 And then equation number 3 with equation number 2. Now, I said my intention is to get rid of the s's. So here, they're already opposites. So I can just add those together immediately. Now here, I have to multiply this equation by 5. So I get negative 10r plus 5s plus 20t equals negative 45. So now the s's will cancel out if I add them together. So I get minus 6r plus 25t minus 49 equals negative 49. So now we can compare these two together. So I have negative 2r plus 7t equals negative 15. And I have negative 6r plus 25t equals negative 49. Now again, we want to eliminate a variable, so I can multiply this by negative 3. So rewriting that, I get 6r minus 21t equals positive 45. So now adding those together, that's 0, that's 4t, and that's negative 4. So t equals negative 1. So now I can plug t back in. So I get negative 2r plus 7t equals negative 15. Add 7 gives me negative 8. So r equals 4. And then now I can plug both the r and the t into the original. And so I get negative 2 times r plus s plus 4t. Now I decided to plug it into the second equation. So I plugged it into the second equation. You get to choose whichever one you want. That one looked easier to me. So I get negative 8 plus s minus 4 equals negative 9. Negative 8 and negative 4 become negative 12. Add 12. Yeah, s equals 3. Okay, so what order do I write these? We'll look at the problem. RST. So R S T. Describe whether or not represents a function. Find the domain and range. So yes, this is a function. No, this is not a function. Yes, this is a function. My domain is from negative 2 to infinity. My range, it's going down forever, and it stops here at 3. So that's negative infinity to 3. My domain here is just 2. My range is negative infinity to positive infinity. My domain here is negative infinity to positive infinity. My range looks like it stops at 4 but goes down forever. So that's negative infinity to 4.